Alright guys, welcome back to this special 200 subscriber video. In this video, I'm going to be teaching you guys how to make a basic maze generating algorithm, a random maze generating program using JavaScript and with the help of a library called p5.js. And let's get into this. So I'm using the Sublime text editor. As you can see, I've already created the HTML file. So basically you want to start off by doing that. Just write that. It's basic HTML. You can give whatever title you want. Generating a random maze. Now I'm going to import the library. So it's called p5.js, but I call it p5.2.js because I have like two versions kind of. But if you want, I can put a link. I'm actually going to put a link of the file in the description below. I'm also going to create a GitHub repository for this project. You guys can just download this project with the libraries included, so you don't have to download it. But yeah, all the links are in the description below. So if you want this library, just check out the description. So this library basically helps us with 2D animations, really simple to use. And so after that, you want to create your script tag. This is where we're going to write all of our JavaScript. Basically, it's going to be around 180 lines of code, but it's not a lot. It's mostly just maths, and it's a bit repetitive, so I think it's fine. So yeah, any p5.js function always needs a setup function. Sorry, any p5.js program always needs a setup function and a draw function. Doesn't always need it, but yeah, you know. And then, yeah, we're gonna create the canvas afterwards, but this draw, and then you can give background. I like 50, so 50 is like grayish kind of. So yeah, and then we're gonna give a const row. Okay, there's a row number. Let's say start off with 20, and then const columns. Let's call it calls, and this is rows. Is also 20, and then const const size. Yeah, size is 20. So the size of each box kind of, each cell. Okay, that's 20. And then over here we can put rows times size. Sorry, columns times size. Columns times size and rows times size. Okay? The reason why I put columns, because think about it, columns go horizontally, even though they're like vertical, they go horizontally. Okay? So there's like a column and there's a next column right next to it to the right of it. But for a row, the next row is below it, and then so on. Okay? So yes, and the reason, and make sure you have these as constants, because then this won't work. Okay? So yeah, now we should see a canvas. There you go. I'll just zoom into this. Yes, just like that. Yeah, this is a really nice setup. You have a console over here, and your output over here. And that's the big mouse. Let me try to get it again. There you go. So, yeah, now what you want to do, you want to create each of the cells, okay? So each of the boxes, okay? So function, where do we do this? We can do this over here. So function cell, and make sure to have the cell C capital, because we're creating a function constructor, a constructor function. Okay, so X, so it's going to have X and Y properties, pretty simple. And then it's kind of a display function, and we're not going to display a rectangle. We're in fact going to display like a set of walls. Okay, so each cell will have 4 walls. So we're just going to draw 4 lines for each cell that shows a rectangle. Okay, so yeah, pretty simple. So what you want to do is stroke 0. So that's the color of the line, and then you want to do this.x. From this.x and this.y, you want to first we're going that way. So imagine a box like that. First we're going this way. So from this.x to this, from this.x, this.y to this.x plus the size and this.y, okay? So this.x plus size, and then this.y. And then line, this is going to be this line going over here. So this is boom, boom, we're over here. This.x plus size and this.y. So from the previous point, and then you want to go to this dot x plus size and this dot y plus size, and now we're over here at the bottom. line from this dot x plus size to this dot from this dot x plus size and this dot y plus size to this dot x and this dot y plus size. Okay, and remember in p5.js and in JavaScript canvas, the y increases downwards. Okay, it's pretty weird, but that's how it works. And then line from this dot x and this dot y plus size to, we're back, this dot x to this dot y. Alright, so now you won't see anything because we actually have to call this function and create cells, so let's go ahead and do that. First I'm going to put var, what is it called? Let's say var track, okay? Or var cells, okay? Is equal to this. It's going to be a 2D array, so, and then we're going to insert it, so var I equals 0. I should be smaller than columns or rows, and then I plus plus. So it's going to go like this, and as it goes this, it's going to go like boom, 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 boom. So that's how it's going to like iterate through all of the cells. And then for var j is equal to 0, j should be smaller than rows I dot length, j plus plus, and then yeah, and over here you want to say var row, and then row dot push a new cell, because remember now there's a instance, we're creating an instance of the function constructor, and now we can put in the x and y values. So this is going to be, the x is going to be calls, it's going to be I times size, yeah, no, j times size, yeah, j times size, and then I times size. Okay, now over here you can do cells.push row. So we're creating a row over here. So we made a row over here. We're adding things to the row, and then we add it to those cells. Okay, so we're creating row by row. And then after that, now we have the cells array. We can display all those elements. So for var I equals 0, 0, I should be smaller than cells.length, I plus, and then do this again. For j equals 0, j should be smaller than cells of the I dot length, and j plus plus. Cells I, j dot display. Okay? Pretty simple. Okay, obviously this is always an error, so let's see. 32. Line 32, rows. Wait, why am I doing that? Oops. It's supposed to be smaller than columns. Sorry. Columns. Okay. There you go. So now you have this, and yeah. So now we have like a grid kind of, and now, yeah, let's go to the next step. So what we want is a constant, another constant, and this is going to be the starting x, so where you start, okay? And let's just say this is going to be at 0, 0, okay? So const start y is also at 0, and then const end x is, let's say that's at the other side, so that's 19, not at 20, because 20 would be over here, and that's 19. Const end y is equal to 19. And then we're going to have a variable called x over here equals to start x, and var y is equals to start y, and these two variables will be the like, I don't know if you saw, I can put it up again, but you see the red thing over there? It's going to be the x and y positions of that, okay? So it's going to be the x and y positions of the current cell that we're working with, okay? So now let's just draw the starting and ending rectangle. So fill 0, 0 RGB, so 2 by 5, rect, get rect, start x, start y, size and size, okay? And let's see, yeah, and then fill this is gonna be the ending one, so RGB, so 2550, rect, and x and y, size and size, and make sure you put time size over here. Okay, so now you have two rectangles over there. That's the start and that's the end. And yeah, so now let's do that other rectangle. Okay, so fill. We're gonna make this rectangle red, RGB. We have all the values, all the colors. Rect at x times size, y times size, size and size. So now we have another one. Nope, we don't. Oh yeah, it's just behind that. Okay. So because this is being drawn afterwards. Okay. So now we go to the logic part. Okay. How do we do this now? So we have to make a function over here that checks what the available neighbors are. And what I mean by available, first I'm going to do this dot visited equals false. So we're going to keep track of which cells have been visited and which ones haven't. So obviously at the start all of them have been not visited, but at the start also the first one, like the one that the current cell is on, that one has been visited. So in the setup function we have to say cells of the start x, yes, start x and start y dot visited equals true. Okay, so yeah, this dot available neighbors is going to be equal to a function where basically yeah, so we're like 12 minutes through. I have to do this a bit quicker. So this dot available neighbors is a function where, yeah, so basically I just wrote this so the time goes quicker. So var x pose and y pose, that's basically it's this dot x over the side. Okay, so that's the x and y positions of the cell that we're looking at. And now we're gonna make an array with all the neighbors. And the neighbors can only be this one, that one, and that one, and that one. So let's say we're referring to this cell over here. The available neighbors can be 4. The maximum available neighbors can be 4. So let's say it's this cell, that one, that one, that one, and that one. So the up, down, left, up, down, right, and left. So if the x position is not equal to the columns minus 1, so if, for example, so over here we're talking about the right. We're finding out if there's a neighbor on the right of this block, of this cell. But it doesn't make sense if, let's say we're referring to this cell over here. There's no cell to the right of this cell. So before calculating everything, we check if the x position is not equal to the columns. The column is 20 minus 1. Okay, and this is 19. So if the cell has a column number of 19, then we don't do this part. Okay, we don't check if there's a neighbor on the right because there obviously is no. And same with these ones, if it's small, if it's not equal to 0, and yeah, you get it. Okay, so this part is basically tiles y pose x pose plus 1. So what does that mean? If it's on the right of a block, let's say we're talking about this one over here, the y pose would be the same, right? Because the y position is the same as the block on the right, as the cell on the right. But the x position would be one more. So if we're referring to this one, the x position of this one would be one more. Okay, so that's why it's like that. And the same with these. And then if we find one, if the neighboring block, if it has not been visited, then we push a neighbor there. Okay, so there's a neighbor on the right, there's a neighbor on the left. But if the neighbor's visited value is true, then we don't push it because that's not an available neighbor, right? So yeah, so that's the function. Then you just return the neighbors, and then yeah, and now we go into the draw function over here. So just before that, I just want to go to the display function. You can see I just wrote a bunch of code, which probably doesn't make sense to you. Maybe it does. We basically want to delete this. Yep, just like that. And yeah, so I basically said if this dot visited is true, so if the block has been visited, then draw a rectangle at that cell, and that is white. Okay, so like just so we can see it. Okay, and then yeah, and then basically over here, if this dot lines shown. Okay, now what is that? This dot lines shown. Over here we have to create another array called this dot lines shown. And oh, sorry, actually it's actually supposed to be like this. So just one object kind of. Right true, left true. Up, true, and down, true. Okay, so which of the lines are shown. Okay, so at the start all of them are shown, right? So yeah, if the right one is shown, then show the right line. If the left one is shown, then show the left line, and so on. But if this value is false, if this line shown to the right is false, then do not show this line. Okay, so it's really strategic that we're using this kind of in this program. So yeah, now we go to the draw function. Okay, so what you're about to see is a bunch of code that are just going to be pasted. Okay, ready? 3, 2, 1, boom. Okay, now that was a lot of code. So let me just. Yeah, so basically if the current tiles, so remember x and y, that's the current tiles. So if the tiles yx, the current tiles, dot available neighbors is 0. If it has no available neighbors, then index minus minus. Now what does that mean? First we're going to create a var index variable over here, and this is going to be equal to 1. Yeah, so actually I'm going to refer to this afterwards, because this is called backtracking, which I'm going to refer to afterwards. So first, over here you can see a var direction. This is going to be a random. You choose from right, left, up, and down. Okay, so there's like a red square over here behind this blue one. It's going to choose a random direction. Now, if there is an available direction, which is all this, so yeah, so if the direction is right, and if it's not over there, okay, then what you want to do is so now you want to check if the tiles on the right has not been visited, then you want to make that tile visited, and you want to there's a track variable, by the way, so var track is going to be equal to an array of just like positions, and since we already start off with a position, we can already put that position over here. That's x, x, y, y. Okay, so yeah, so you basically want to increase the index, and the index is basically the index of the track. Okay, so the index of the current track is basically what position are you looking at in the track. Okay, so all of this will make sense afterwards. So just ignore the index part. I'm going to explain that afterwards over here. So yeah, so you want to track the splice. You want to insert basically a position. So the position that is on the right, you want to insert it at the index of the track. Okay, and 0 basically means you don't want to delete any elements. You just want to like insert it. So that's that. And then what you want to do, let's say we're over here. Okay, we move right. Basically, this wall over here will be removed, and for this right cell, the left wall will be removed. Okay, so that's what we do over here. And then x++, we basically want to increment that red square to the right. We want to move it to the right, so x++. That basically happens over here. Okay, same thing, just with up and down, left. It's really simple. You can see it's like really repetitive, and that takes like what, 143 to 107. That's like almost like 40 lines. Okay, so yeah, after that, now I can explain this. So let's see what this produces. An error. Okay, tiles is not defined. Oof. So 102, let's see, 102 tiles is not defined. Yes, that's right. So this is actually supposed to be tiles. Sorry. Let's make this tiles. Yeah, so you can call it cells or tiles, but in this case, I was supposed to name the array that we keep track of tiles and not cells. So yeah, that's that. And cells is not defined. Where is that? 95. Yeah, obviously. The tiles, and then tiles, cells over here. Alright, yeah, so now you see that it's working pretty good, and you can see it's also backtracking. Okay? And what I mean by backtracking is like if it gets stuck, we get like 3. Yeah, so that red square, it's moving, and the reason why it sometimes stops is because it may have picked a direction where there is a block, so it basically chooses a random one. Okay, so like over there it stopped, and yeah, let's just wait until it basically comes to a dead end. Yes, turn left, please turn left. Yes, thank you. Okay, so it's gonna come to a dead end soon, and what you will see is the reason why I did index minus, yeah, so it's come to a dead end and now it's going backwards until it sees another cell with an available place to move. Okay, so now it's going to come to a dead end again. It's going to come back to this cell because this one has an available place. It's going to fill all of that. Now it's stuck again. So it's going to go all the way back over here. And now it comes over here. That's an available spot. And it does that so on. And it fills up the maze. But eventually what you will see is that it will get stuck. And the reason why it's going backwards is we did that over here. If there are no available like places to move, so if it's stuck, then you want to index dot minus minus. Okay, so you want to like move it backwards pretty much. Okay, and as you move it backwards, you want to change the x and the y position of that rectangle by the track, by the position. So yeah, basically what this means is you want to move it backwards, and then so it keeps moving it backwards, and then it keeps checking this, and then let's say so it goes over here, it moves over here, and it sees that there is an available spot over here to move, so then it runs all this. Okay, so else, that's where the else comes in. So yeah, that's that, and we're almost done actually. Frame rate, let me just increase that to, well, let me just delete that. So this is going on, and what you will see at the end is it's going to complete the maze, but there's going to be an error at the end, which we're going to fix, because at some point the index is just going to be minus minus, and it's going to go to -1, which is undefined. Yeah, there you go. Okay, so cannot read property of x undefined at 104 over here, because we did index minus minus, and it was right now it's -1, the value of index. So index is -1. Okay, and you can't have an array with a -1 index, right? So yeah, so what we have to do is let's see. Yeah, so we basically have to tab all of this. So just tab that and put an if statement around it. So if yeah, actually I'm going to put an if statement over here, and yeah, this is becoming really messy, but else. Okay, so I'm going to put an else statement over there. Yep. So if count is 0, and what is count? Okay, so now over here we have to check if all of the cells have been made. So if the maze has been made, so for var I is equal to 0, I should be smaller than tiles dot length, and then j, we're going through the columns now. And now we basically put a count variable over here, so var count is 0, and count if tiles of the I, j dot visited is not equal to 0. Sorry, it's not equal to, if it's equal to true, no, if it's equal to false, yeah, then count plus plus. So this basically checks how many cells are still remaining to be filled out. Okay, and then if yeah, so if it's 0, then that means that there are no cells remaining to be filled out. So then you'll just say no loop, so we don't run anything anymore. Now I'll just make this yeah, I'll just make that 10, 10, 10, 20, and 9, and 9, and 9. Okay, so it's gonna be quicker, and yeah, let's see what happens. Yeah, so stop's over there, but then we also have to get rid of that red rectangle. How do we do that? Okay, so the red rectangle is kept over here. So take that and paste it over here, I think? No. Because you want it to be on top, so over there. And what you can do, you can display these again. Yeah, I guess you can just display them again, so just display all of the tiles again on top. Okay? So we'll see what happens. yeah, there you go. That works. And another problem, you can see there are no lines over there, and that's because the canvas isn't big. And like it needs to be 1 pixel big, 1 more pixel like wide and deep kind of. So +1. Yeah, and now you can see a fully successful random maze generating thingy, okay? And with this, what I'm going to do in the future, I'm going to make a 3D version of this. I'm going to plug this algorithm in 3D and make a 3.js 3D maze, a random maze, and then you can actually play it, so you can move around and everything. You can also apply that over here, so you can check for collisions between the walls and make a player move from here to here and check from here to here, and check if the player has made it. And then maybe you can put like a time over here. So yeah, so you can take this algorithm like to another level, and like, yeah, it's quite easy. But I'll put a link to all the credits and all the references I used for this video in the description below. If you want to check those, you can. And yeah, thank you for the 200 subscribers, I guess. And yeah, I'll see you guys in the next video.